Today we've been investigating object-oriented programming, and we spent a great deal of time with creating the class, the blueprint, by defining its fields, its methods, and just previously its properties. But there's also the act of creating an instance of that blueprint, of that class, and we call that process instantiation. The way we instantiate an object is with the new operator. That's what the new operator is for. So take a look at this example. I have a class called kite, and here I want to define a new instance of kite. And so what's going on in these two lines of code? Well, in line number one, I'm creating a pointer to a kite object. The pointer is called myKite. Think of the variable myKite as like a string, not like, a string of letters. I'm talking about a real physical string that's connected to a kite, okay? But right now it's not connected to anything. It's just a string laying on the ground. It just has the potential to be tied to a kite object. In line number two, I'm creating a kite object using the new operator, then tying the string to it. Now, whenever I need to work with the kite, I can just use that string, which, to extend the metaphor, is the myKite variable. So myKite is the way that I hold on to an instance of kite in the computer's memory. See that distinction that I made? There's a difference between the object as stored in the computer's memory and the pointer to that object, which I hold on to, and that's a variable. Okay? So why am I making this distinction? I just want to provide a little background which hopefully serves as a mental model of how objects work in physical memory. There are two ways that an application uses a computer's memory, and by application I mean really the .NET Framework runtime. It organizes some of it into an area called the stack, and some organized into an area called the heap. When you think of the words stack and heap, what do those words convey to you? Well, to me, the stack sounds like an organized grouping of information or things, right? And the heap sounds unorganized. Just throw it in a heap in a pile in the corner, okay? Just a bunch of stuff thrown together. And that's pretty much the distinction. The stack is where value types like integers and other simple types are stored. It's organized and easy for the application to find what it's looking for because it knows the exact size of each of those objects, and they're typically pretty small. The heap is where reference types, like the string object, like the date-time object, like your custom objects are stored. Since they're both variable in size and typically much larger, they're piled in the heap wherever they're going to fit, okay? The only way to keep track of what's in memory then is through the reference. A variable, which, like the variable myKite, is stored in 4 bytes in the stack. So it's a pointer to a memory position in the heap where the actual kite object is stored. So as long as I'm holding the myKite reference variable, I can get back to the kite object in memory and work with it. All right, so key takeaways so far. There's a difference between the variable that holds a reference to the object in memory and the object in memory itself. Okay, those are the two main differences. So in our case, there's a difference between the string that I use to hold onto the kite and the kite itself. The string is a reference. It allows me to get back to the kite. The string is stored in the stack. In this case, the variable name myKite is stored in the stack, and what it is an address location. We look up that address location in the heap, and we find the object that we want to work with. In this case, our instance of the kite object. Okay, number two, the reason why you need this setup of references and objects is because of the physical method which is used to store information in the computer's memory. In order to store things efficiently, this is the system that they come up with. All right, so hopefully that provides enough background and it didn't blow you away, and we can use this as the basis to expand on this conversation. All right, so take a look at this line of code on screen, new kite. What do you think? Do you think this would work? Well, a new kite object might be created in memory, but since there's no reference to it. In other words, there's no string to hold onto the kite. There's no reference variable to point to it. You would never be able to do anything with that new instance of kite. There's no means of accessing the kite. To overextend the analogy, the kite just flies away. Okay? So let's take a look at another section of code here. What happens here? Kite, my kite. My kite equals new kite. Okay, so now we have a reference to a kite in memory. We set a property of our instance of the kite class called color, and we set it to the value blue. And then we take that same reference and set it to a new instance of kite. What do you think happens here? So in this case, what I did, first of all, was I tied my reference variable to one kite, the blue kite, and then I tied my reference variable, the string, to another kite. So what happens to the blue kite? Well, since there's no variables that are referencing that object, it flies away, or rather it's removed from memory by the .NET framework. The .NET framework has something called garbage collection that goes around and looks for all those objects that have been abandoned, that have been orphaned, and it gets rid of them. Okay, cleans up. We'll talk about more about that in the internals of the .NET framework at a later date. Okay, so a single variable can only hold a reference to a single object in memory. Also, when an object has no references to it, it is removed from memory. Okay, another example. How about this? Kite, my kite, kite, my other kite. So we've created two references. Set to nothing so far, right? My kite equals new kite. Okay. My other kite equals my kite. Huh. All right, so I have two references. I create a new instance of kite and tie one string to it. And then I reference that string or that reference variable and say, yeah, I want to reference the same thing. What do you think's happening? So if you guess this, that, in fact, here, let's play a little game. I'm going to give you two choices, okay? Here, it's either one of these two. Is it A, there are two kite objects in memory now that are identical? Or is it B, that there are two reference variables that are pointing to the same kite object? If you answered B, you're correct. There are two reference variables that are pointing to the exact same object in memory. All right, this is an important concept because we're going to be working with reference variables and objects a lot from this point on. So don't miss this. Rewatch this video if you have to. It's that important. So let's do this. Let's back up and take another pass at this. Here's the kite class. It's pretty simple. And I'm only using public fields. Stay with me for now. We'll just make this simple. We have a public string color, a public integer width, and a public integer height. And then we have a method called fly that returns nothing. All right, it's a simple class. As we have been saying, the class is simply a blueprint. It defines the construction of a new kite object. It's not the object itself. It's just the plans to create a new object. To build a new kite object, we have to use the new operator. Or think of a class like a cookie cutter. We can stamp out a new kite object when we use the new operator. So I can just keep producing new kites by calling the word new. There is one puzzling detail before we conclude today's or this particular video. Why do we have to use the parentheses after the word kite in this example? We already said that the parentheses are the method invocation operator. So when we called write line and we added the parentheses, or read line and used the parentheses, we indicated that we wanted to invoke those operations. Those were methods. So what are they doing here? Why do we have them next to our class? In this case, kite. Why does kite have a set of parentheses after it? When we create a new instance of a class or a new object, we are also calling a method on the object called its constructor. The constructor method gives us a chance to initialize the object immediately before we use it. Now, in the case of our simple kite class, we don't see any other method defined here. I mean, let's take a look at our work with with the auto class, we don't have a constructor defined here. We just have, a couple of simple methods defined and some properties. So where does this constructor live? So here's where I'm going to keep you hanging until tomorrow. I can't answer that question just yet of where the constructor is. We'll just talk about constructors soon, just leave it at that. I just want to acknowledge that in the context of this discussion about object instantiation, that there is a set of parentheses, there is a method called a constructor. We don't see it yet. Where is it? We'll get to that soon. Okay, so hopefully this answers the question of what the new operator is. The new operator, we called it a factory. It's like a cookie cutter. It stamps out new instances of objects in the computer's memory. We have to then reference that by using a variable, which we call the reference variable. The reference variable is stored in the stack part of memory. It's just a pointer, an address to the actual object that sits in the heap. An address is simply just like on your house. I live at 4110, okay? So it can find me easily if it has that address. The same thing is true here. So hopefully that didn't confuse you too much. You'll never really have to know the internals of addresses and things of that nature. The only place where it really bites you is where you start swapping or reusing your reference variables to point to existing or new instances of objects in memory. So we'll leave it at that for now. We'll pick it up in the next video. You're doing great. Just hang in there with me. Do the exercises at the end of this lesson. Hopefully that will help to solidify some of these ideas in your mind. Okay, we'll see you in the next video. Thank you.